Here is our most complex example so far. A circuit with 3 unknown node voltages. Node V1 connects to node V3 through a 6 ohm resistor, highlighted in red, and to node V2 through a 12 ohm resistor at the top. Node V2 also connects to V3 through a 4 ohm resistor and to ground through a 6 ohm resistor on the right. Node V3 connects to ground through an 18 ohm resistor. A 5 ampere current source enters V1 from below. Our task? Find the current I through the 4 ohm resistor and the power dissipated by the red 6 ohm resistor. Let's write KCL at node V1. 3 terms. The 6 ohm resistor to V3 gives V1 minus V3 over 6. The 12 ohm resistor to V2 gives V1 minus V2 over 12. The 5 ampere source enters V1, so we write minus 5. Putting it together, V1 minus V3 over 6 plus V1 minus V2 over 12 minus 5 equals 0. Multiply through by 12 to clear denominators. We get 2 times V1 minus V3 plus V1 minus V2 minus 60 equals 0. Combining, 3V1 minus V2 minus 2V3 equals 60. That is our first equation, KCL at node V2. 3 branches, no current source at this node. The 12 ohm resistor gives V2 minus V1 over 12. The 4 ohm resistor to V3 gives V2 minus V3 over 4. The 6 ohm resistor to ground gives V2 over 6. Equation: V2 minus V1 over 12 plus V2 minus V3 over 4 plus V2 over 6 equals 0. Multiply by 12. We get V2 minus V1 plus 3 times V2 minus V3 plus 2V2 equals 0. Combining, minus V1 plus 6V2 minus 3V3 equals 0. Equation 2, KCL at node V3. Again, 3 branches, no source. The 6 ohm resistor gives V3 minus V1 over 6. The 4 ohm resistor gives V3 minus V2 over 4. The 18 ohm resistor to ground gives V3 over 18. Multiply by 36 to clear all denominators. We get 6 times V3 minus V1 plus 9 times V3 minus V2 plus 2V3 equals 0. Combining, minus 6V1 minus 9V2 plus 17V3 equals 0. Equation 3. We now have 3 equations with 3 unknowns. Equation 1. 3V1 minus V2 minus 2V3 equals 60. Equation 2. Minus V1 plus 6V2 minus 3V3 equals 0. Equation 3. Minus 6V1 minus 9V2 plus 17V3 equals 0. To solve this system, we use elimination. Multiply equation 2 by 6 and subtract equation 3. V1 cancels, and we get 45V2 minus 35V3 equals 0. So V3 equals 9/7 of V2. Substitute back. V2 equals 21 volts, V3 equals 27 volts, and V1 equals 45 volts. Quick verify at V1. 45 minus 27 over 6 is 3 amperes. 45 minus 21 over 12 is 2 amperes. 3 plus 2 equals 5, matching the 5 ampere source. Correct. Now for the two quantities the question asks. The current I flows through the 4 ohm resistor from V3 toward V2. By Ohm's law, I equals V3 minus V2 divided by 4. That is 27 minus 21 over 4, which equals 1.5 amperes. For the power dissipated by the red 6 ohm resistor between V1 and V3, the voltage across it is V1 minus V3, which is 45 minus 27, equals 18 volts. Power equals V squared over R. 18 squared over 6 equals 54 watts. The main takeaway? The 4-step nodal method scales directly from 2 nodes to 3 or more. The only difference is bigger algebra, 3 equations instead of 2. Once you have the node voltages, Ohm's law gives any branch current, and P equals V squared over R gives any resistor power. In the next video, we'll see one more nodal analysis example.